Okay guys, so let's talk about debuggers. Debuggers are basically programs that will allow you to execute code, programs in this case, Windows binaries, step by step, which is very helpful because you want to know how the program executes and you want to go into the details, right? So that you can understand what it is doing. One of my favorite debuggers is called Immunity Debugger, which is created by Immunity Inc. Basically, actually they didn't create it, to be honest. They took a previous project called Oli Debug, which was a pretty cool debugger. So they took it and they just added Python support. I mean, basically, they might add other things, but yeah, they added advertisement in the purple color. But it's pretty cool actually. It has a Python support, which means you can do the debugging, but also you can add scripts, plugins in Python to automate your analysis. So as usual, we're gonna open any binary. Here we have our hello binary. And in the left side, you will have all the instructions being executed. As you can see, the debugger is going to stop in the entry point as usual, but you can control that in options, debugging options. You can go to events, and here you can tell, instead of stopping in the win main or entry point, which are kind of similar, stop in the system breakpoint. What is the difference? If you remember when we talk about TLS, TLS is a feature that will execute, if present, before the entry point. And I told you that when we are analyzing malware, if we want to stop in the entry point, by the time we reach the entry point, we are already infected in our machine, which means probably we cannot do anything. If it is ransomware, which is a malicious software that will lock your computer, you will need to restart it, and hopefully you can recover it. So by using the system breakpoint option, it will jump right in the first instruction of the program, right after being loaded in memory, so you can always start executing even before the TLS callback. Okay, that's one of the reasons. You can also put break on new module. Break means stop on new module being loaded, like every time a new DLL is being loaded in memory, when the program is running, it will stop so you can check it, what's going on. And that's pretty much in this area. Okay, so in the right side we have the registers, the CPU registers for x86 architecture. We have, as you can see here, EIP, which is the register point to the next instruction to be executed, in this case the entry point. And in the bottom left we have the memory, so we have here everything that we want to search or analyze in memory. And in the bottom right we have the stack, which basically means everything being executed in the stack, normally functions being executed when we call different functions. ESP is pointing always to the top of the stack, as you can see, FF90, 23 FF90. Okay, so in order for us to start executing, we need to step into, which means go instruction by instruction. That is with F7. So you press F7 and you start executing again. And if I click F7 in this call, it will step into that function. But if you don't want to step into the function, you just click F8, which is gonna go over it. Okay, so that's pretty cool. And here we have another function. We can also click step over. You see that that looks like it did something, and it is saying it's running. You can see here status, so it just, I think it just pop up the hello, which is just the purpose of this specific program, right? and it terminates. It says terminated, and that's pretty much it. Okay, guys. So let me show you something called breakpoints. So the breakpoints means that you wanna stop the execution at a certain offset, or a certain address, right? And the reason of that is because sometimes you just want to skip instructions and go directly into that specific address, or sometimes you already analyzed all the malware and you just wanna restart the debugger, but right after that jump over into that specific instruction. Or another option is you have a loop which is gonna repeat 500 times, and you don't wanna keep pressing F7, F7, F7 500 times. You just put a breakpoint after the loop and it will just go straight there. So I mean, there are different options, and there are two different kind of breakpoints: software breakpoints and hardware breakpoints. The software breakpoints is you just press F2. So let's say that we wanna stop right here in 401180 just before printing the message box. So we'll click F2, right? What it is doing, the debugger, is internally is gonna put a specific offset, sorry, a specific opcode. An opcode is a byte. In this case, CC. It's gonna put that opcode so that it can tell the debugger, when you find CC in that specific offset, stop. The debugger is not showing us the CC because it wants us to present the same instruction for us, but internally, behind the scenes, it is changing it to CC. So that's why it's called a software entry point. Software breakpoint. And you have unlimited software breakpoints. You can put as many as you want. And we have also hardware breakpoints. Hardware breakpoints, you can only put 4. And those ones are based on the CPU. That's why the limitation. And the main difference is that for software breakpoints, as you can see here, the program must try to execute it so that it can hit your breakpoint. In other words, if I put a breakpoint on 4012v0, the program must go through it in order for me to hit my breakpoint. But what if the program doesn't execute that instruction? We will never reach our breakpoint, right? So the hardware breakpoints can allow you to say, hey, not only stop on execution, because it's also possible, but also stop just when the malware is writing information in that specific address. You know what I'm saying? It's not only executing, it's also writing information or accessing that specific, not even writing, just accessing that address. So you have more pretty cool information, options in hardware breakpoints. For example, a very well-known scenario is that the malware, it is writing information into a specific address in memory. So you will tell with a hardware breakpoint A, and let me show you how you do it. You come here. So let's say that for 49,000, it is the malware writing something, right? So you want to stop the execution when the malware is writing something in that address. So you will come to the memory window, and you will click on breakpoint, hardware on access, byte, which is 1 byte, word or double word, or hardware on write, which means if someone is trying to write something there, or on execution, which is similar to the software breakpoint. So that's kind of the way it works. I'm going to show you how it works in a second. So basically we have here the software breakpoint. If we click on play, you can see that it just executes right away and went straight to that specific address pointed at 4012v0. EIP is pointing to the same thing. So that's basically the way it works. Now, At this time, I'm going to introduce also the disassembler, which is called IDA-Pro. And the reason of that is because, as you can see here, it's kind of hard for you to understand what is going on, right? So I highly recommend to combine IDA-Pro to check the assembly instructions and the debugger to know what is exactly being executed at runtime, and with that combination you can understand the malware. So let's go and click on IDA-Pro. So IDA-Pro this is the free version, but usually when you work as a reverser you will have a license being paid by the employer, so don't worry, which is powerful actually. So we open it, our hello here, and IDA is starting to process that. And what I want to show you here with the disassembler is I'm going to go to the same address that we are here right now. It is 4012B0. Okay, so I'm going to click I'm going to press the letter G for guess, and I'm going to put the address 40. What was the address? 4012B0, and I just press enter, and we are here in that specific address. We have two views. This view is kinda pretty cool because it can show you the loops, everything, but if you press the space bar, you will have a second view which will show you also the addresses, so that you can confirm you are right in the same place. You can also tell IDA in options general to print the opcodes. You can see here the number of opcodes to print. Let's say it can be 7, which is kind of the enough size of opcodes, which opcodes are instructions. So let me quickly explain you that. So for the call that we have here, we have 5 opcodes: E8, CB, FE, FF, FF. That represents a call to this specific relative address. You can see here, for example, a sub, which is a subtraction in the register ESP, and you are subtracting 1C. So that's reflected with this opcode 83, which is for subtraction, EC, which is related to ESP, and 1C, which is related to the 1C number to be subtracted. So that's the reason of opcodes and how IDA translate them. But you can always put them, because if you want to add detection at binary level, you might want to know what are the opcodes in those specific instructions. Okay, so now that we are here in the same location, we can start trying to find what is the message box, right? So that, because we don't know, I mean, we click here, I don't see any message box here. You guys see something? I don't see anything. And probably if I go here, also I don't see anything. I just see many instructions, right? So IDA is gonna help us a lot here. So how we can find it? We have many options. One option is go to the imports tab. In the imports tab, we can go to message box. We need to find the message box, which I miss it. Is right. It should be in user 32 right here. We double click it. Okay. We click on it again, and then we press the X key. The X key is gonna show us the cross references, which means where are the addresses calling message box. If we click OK, we're gonna be sent to that specific address. So here we know where is our message box, right? A pretty cool option in IDA is that we can document everything. So here in this function, we can press N and say, this is my message box function. It says the limit has been exceeded. You wanna do it? Fine, no problem. And here we can start tracing back all the way to the initial instruction where we are in the debugger. So we click X, it's gonna say, okay, this specific function is being called right here. We click OK. So we are now in this specific function. So we know that this function eventually will lead us to the message box as we saw. So we can go here and say n to rename, and we can put something like to message box so that we know the flow. Again, we select and click X and we go back, and you can see that this function is the 401180. That's exactly the function that we are just in the debugger waiting for execution. But now, thanks to IDA, now we know the flow. It is here all the way down, and it will reach our message box here. So at this time, I'm gonna show you hardware breakpoint. So we know that at this instruction, it is located at 4012 4B, right? 4012 4B. So we can go to the debugger. We can use this command prompt, which is pretty cool. We can say dd 4012 B2, I think. Oh man, I don't have good memory. 4012 4B. 4012. Okay, 4012 4B. We press enter, and that's gonna print the content of memory for that specific chunk. Okay, so here we can right click and say breakpoint hardware on execution, which means it is similar to the software but it's hardware based. If you want to see your hardware breakpoints, you go to debug hardware breakpoints, and we can see that we have our 4012 4B stop on execute, and you can see that we have only 4 available. You can always delete one to have more availability. 4B. Okay, so I'm gonna let it run here again by clicking on play or pressing F9. You can see at the bottom it says hardware breakpoint 1, which means it hit our breakpoint exactly at 4012 4B. You can quickly go to EIP and see where it's located. The instruction 4012 4B, the instruction to be executed. That's also pretty helpful. So that way we can go back and forth between the debugger and the IDA Pro, you know, so that you guys can understand properly what is going on. So when we go here to the message box, we can clearly see that there is a call to message box, which is actually the API, and it's gonna print hello, and welcome message is the title. If we click on message box, we're gonna go to the API. You can see there is no more code. It is just this pink color. And what I want to show you here in pink color is you can see here in this bar, the pink color means library code. Library code means code coming from the DLLs, in this case from user 32. That's very important, guys, because sometimes if you want to analyze code in IDA, skip everything in pink color, because you are going to try to reverse APIs which are already there. Let's say that you don't pay attention to the message box, pink color, you might want to get into a function that you don't know what it is doing, but we all know it is just a message box. But if you don't know that, you only will see assembly code, and you're going to spend too much time trying to analyze something that it is already known. So keep in mind, if you see pink color, skip it. It's library code. So we click on escape to go back, escape again, and we are back to our instruction set, and the custom code is in blue color, as you can see in the bar. Okay, so now we're here, we're ready to execute. So I'm gonna show you another thing. Here is 4080D5. So we're gonna go to, if we go here, click on this option and then click enter, we just get into the function. We are not executing, see where it is EIP. EIP is exactly in the instruction to be executed. We are just browsing the software. If we want to go back in the debugger, we click the minus sign and we go back. If we want to go forward again, we click on plus sign. You see, guys? Okay, so I'm just gonna go here and I'm gonna show you another feature here. If you click Ctrl G, it's gonna say expression to follow. You can put here the address you wanna go. In this case, we wanna go to 4080D5, 4080D5, which is the message box, as you know. And what I'm gonna do is I'm gonna put a breakpoint here, just a software breakpoint in this case. It doesn't matter. And what I'm gonna do is I'm gonna run what is called a trace into. So if we click on, we put a breakpoint, we are not executing anything yet. So we are just gonna go back with the dash or minus sign key. Sorry, dash or minus key from the keyboard. We click it, and finally we are back. And we can always see where we are located by looking at EIP. So right now I don't know where we are, but by looking at EIP, I know we are right here. Okay, I'm gonna click on debug trace into. Trace into is pretty cool because actually it's gonna run step by step every single instruction, but it's gonna keep recording the state of the registers and the state of every single execution, so that if you want to trace back all what was just executed, you will be able to see exactly the status. That's pretty useful because sometimes when you run just with breakpoints, if you want to go back and check what was the previous value of EAX or EBX, whatever, you cannot because you didn't trace it. It won't be stored. So you just have the latest value and you don't know how it was calculated. So that's why it's pretty cool. So, and the way it works is that you put a breakpoint and then you just call trace into. Let me just remove my hardware breakpoint so that it doesn't interfere, and then we just click on trace into. It went so fast we didn't even notice, but it stored all the instructions. If we click here, guys, with the minus key again, you're gonna see, check the registers, how they are gonna start changing. And it is in blue color because it's saying I am showing you what was recorded. We keep going. You see ESP changed, eventually ECX changed at that specific instruction. Then eventually we got to another call, and you can see how all the instructions being executed were changing until we get to the initial point. That's pretty cool because that way we know exactly what was changed. So what if we, and then I press the plus button, right, to go forward. What if we want to know, like, hey, what was the value here in ECX? So that's, or what was the value before entering to this specific function? So that's the power of trace into. Okay, and now it removes the blue, which means we are done with the trace into. That's pretty powerful, keeping in mind if you want to know at certain point of time what was the different executions and calculations of the registers, and you don't want to go line by line pressing F7, F7, F7. You just want to run it quickly, and then trace into is going to help you. So finally we're here, and then we click F8, which means go over. And by going over, as you know, it's just gonna pop up the message box. Okay, so that's basically the principles of the debugger. And here in IDA is pretty cool because you can have also the names here are the symbols in the binary. You can have the strings also. The strings is pretty cool also, because sometimes, let's say that you want to find a specific string that you don't know you don't know what the malware is doing. You just click on, let's say, the welcome message string. It's gonna point you to the string here, and then again you click on with X, which is the X reference, and it's gonna take you to the exact place where that specific string is being used. Another pretty cool tool from IDA is the Xrefs graphic, which is going to show you how you can reach to that specific point. Let's say you want to know how you reach that message box, right? So if you remember, we were here located, and then we want to go to the message box. Let me change the view, which is this is better. So we just go to the message box, and finally we get here, right? So if we go to graphics, in view, graphs, and we click on Xrefs 2, check this. It's gonna tell us the X reference in order to get to the message box. You can see that it traced exactly what we just detected manually. To message box, then message box, and finally the API, which is in a pink color, which is the library code. It's telling you there is nothing else after that. This is pretty simple, right? But it's pretty cool, and it's gonna help you to know the flow of the program. And in this case, it's pretty simple. It's small, but can you imagine having 100 functions that you don't know what it is going on? So it's going to help you to have a better overview. There are many other functions in IDA, but so far I think we covered the main ones. Don't worry, we're going to have also courses with exercises so that we can also practice assembly and other stuff. So hope you enjoy it.